Okay, it looks like we are live, so welcome back. Today I'm going to be continuing to work on my Hashmap. So let's take a look at what we got. The stream actually crashed yesterday, so you didn't get to see the end of what I was working on. But now it does work. Does work as far as I can tell. So we can put in map a few different things. And we just handle the error each time. And then I was doing some testing, and so I just removed this from the map, and then tried to get it again. So if I actually compile that, we would expect an error, and that does happen. So that is good, but we can still get that would still work. 20, that's perfect. And I had it set actually to 1 being the size for testing purposes, but I don't need to do that. It still works without that. So we can get that. If I don't remove it, we can still get what as well. Just like that, and there we go. So we can place stuff in the hash map and also retrieve it. And it works with a linked list, so there can be collisions. Yeah, so it actually is all working now as far as I can tell. One very important thing is yesterday I was working on it, and I was actually allocating space for this, but then I was just setting it like the current key equals key, and that was actually just moving away. Just a brain fart. So now I'm actually doing it properly. So we're allocating space, and as far as I can tell, there is no memory leaks. Yeah, so I just valgrind main, and there we go. It says all heap blocks were freed, so that's pretty good. Yep, so that is good so far. Yeah, we can insert stuff. The only problem basically now is, well, we don't have a way to print it. That's useful for debugging and testing and such, but also you can only store integers, and I would like to be able to store any data type essentially. So that is what I'm going to be working on today. First of all, I'm going to have that print map though. So I think that can go right here. Whoops. So just void print map. And we'll just take the map, and then we'll just iterate through, and then print. Well, we'll need to like format it in a special way, but basically we can just do I equals 0 while I is less than hash map size I plus plus, and let me make this size t rather for safety purposes, because we're writing in such a safe language. Okay. Anyway, and then we will just print f. So we will print the value. For now, it'll just work with the integers. Print the value in the key. So let's print the key. The key is always a string, so we know that. And we can just do. Actually, we need to go through the nodes. So I will just allocate a node here. And that'll just initially be set to map hash map I. There we go. So we set to that, and then we'll just go through. So then basically wall node does not equal null. We'll do this. And then we will do actually I need to provide it here. So node node key and node value. And then node equals node next. Something like that I think will work. And we're not freeing it or anything, we're just printing it out. So if I did everything right, before we free the map, we can just call print map and pass the map in there, and let's see if it works. Okay, so it compiles, and it looks like it actually did work, so that is pretty good. Here we're printing the value. We don't need to do that. Yeah, so we should be able to add more stuff to the map, and then it'll print out. So if I just get this, do this, do this a couple of times, and then we can just use whatever keys, whatever. We can even use numbers as the key, except string of numbers, but yeah. So then we get all that. Okay, so that's pretty good, and it's actually in the, it's not in the order that we put it in, so it's in the order that it actually gets placed in the map based on the key. Something that would be useful though is to actually not print it with a new line, and maybe do something like printf null new line at the end. And here we just do an arrow, so then we can see which ones actually like collided. Okay, let me put a space actually. There we go. And it looks like none of these collide. Oh, okay, actually there's a collision. Let me change that from 10 because that's a little confusing to look at. I think there we go. Doesn't really matter what it is. And there we go. So we can see we get what, and then it collides. So it is actually the next element, and then it goes to null. So yeah, we get a good idea of how the hash map looks like this. And this is actually 10 elements, because that is the size. So the only problem with this is if I make it rather large size, what you might want to do when you print it out, you get a whole lot of nulls. That's not exactly ideal. So if it's just a null element, then we'll just kind of skip over it. I think that would be a good idea. Basically, we can just do if node equals null, then we'll just skip. So I think we can do something like that. Let's see. That's not what I wanted to do. Alright, and then we run it, and perfect. So yeah, now it doesn't print it. It prints the null, because that way we can tell where the end is. That is why I added that. But otherwise, it won't print any of that stuff. So, that's pretty good, I think. I think that is quite good. So yeah, we can see how the hash map sort of forms. If we change the hash function as well, because right now I'm just using a random thing. Yeah, we can just change it to be +2, something like that. +2, and then it's just going to completely change the order of the map. You can see, yeah, we have whatever is here now, and then hello, and all that stuff. So that's everything that we have in the map. Yeah. So that is pretty good, I think. And 10 is a good size where you can still look at it, but there's still sometimes collisions. So that's pretty good, actually. Alright, so now, void pointers. That is kind of what we need. So we could technically, I think, use like a union. Just a union. And then you can have, you know, int as int. And then you can have char star as char star. Stuff like that. But that doesn't exactly work. Like you have to add each individual one. And you have to know what the type is when you're getting it. Things like that. Whereas with a void pointer, I can actually show you. So the value void pointer. So that's going to break everything. It's not going to work anymore. Yeah, you can see this. So let's actually change some stuff. So when we place something in the map, put in map, let's actually take that. There we go. The void pointer for it. And then, so we set the value equal to value. So that's fine if it's just something that is actually, that's probably not fine. So we need to actually allocate space for this as well. So, and then we'll have to do like memcopy. Yeah. So, how do we want to go about doing that? Because we don't really know the data type of it. All right. Well, we'll just not worry about that for now, and then we'll get to that. Because we want the lifetime to be as long as you want it to be, essentially. So let's see what we can do here. Okay. So where are we setting the value? So this is putting it in the map, and then index equals current. So we're actually, this is where we set it actually. So, yeah, actually we need to go to 86 right here. Yeah. So get from map. We want this actually to be a void pointer. Whoops, and I just closed it. Okay, let me open that back up. All right. So void pointer, and now, yeah, we don't actually want to dereference it. We just want to set the pointer value equal to that. Yeah, here as well. Alright, and let's see. Yeah, so now we can't actually pass just an integer like that. We need to pass a reference to it. So, yeah, let's just make int value equals 12, and then we can just pass, we might still get an error for this. This value like that. We might have to actually cast it, but I am not sure exactly. So let me get rid of some of this extra stuff. Yeah, something like that. So let's do that. Build it now, and we have redefinition of value. So yeah, let's not call it value. Let's call this one okay, sure, it doesn't really matter. This is just for testing purposes. And we'll get rid of that one as well. Okay, and now let's build this, and we have some issues. So unused variable value, so we can just get rid of that. So we could have called it value. Value set but not used. Okay. Because we don't get something from map. So let's actually get it from map. So let me put value back. And then let's do error equals get from map, and then what? And we'll just pass the value in there, and then we will print the value. So handle error, and print f value. There we go. So let's see what we get. And okay, value set but not used. So what is the deal with that? Format specifies int. Okay, so that is, yeah, that's actually in the print function, because the value is not that. So we'll just cast it to an int. So that's not exactly going to work, because we'll need to know the data type, but for now we can just do that. Okay, no, I see. Cast it to, yeah, an int pointer, and then we have to dereference it. There we go. And then, now, value is set but not used, so I don't know what that's about. Hmm. Value equals that. Okay. We're setting it here, so why is it not used? Uh-huh. Okay. So, let's see. What can we do about that? So we want it to point to this current value. So why? Alright, well, let me see what happens when I run it. It's not gonna work. Okay, so we do actually get the values in there. 12 and 12. But then when we try to print it out here, let me move this up here actually, because I think that'll be a little less confusing. So yeah, we try to get it and it is 0. So that is obviously not ideal. So the get does not work. Okay. That's removed. Let's see. So value, we can't dereference that. So how do you, how do we update that? Okay. Can we return the value? Okay. Yeah, can't do that. What if int pointer? Yeah, that's not gonna work. Alright, let's see. Yeah, that's not supported. That is what I thought. Yes. Try asking ChatGPT? Yeah. Okay. Sure. Sure thing. Let's see if I can open it up. I might have to sign in. Let me see. Okay. ChatGPT. Okay. I'll just do that. What does it say? It says why value set but not used. There we go. ChatGPT. In pros. Okay. Let's see. The function. Alright, so it has to return the value directly. Alright, no, but I don't want to do that. I don't have 4.0. You have to pay for that or whatever. Yeah, I don't have plus. I'm not gonna pay for that. So, yeah. Oh, but there's like free front ends or something? Let's see. Is there one? Maybe. I don't want to sign in either. Okay, poll. 1 query per day. Alright, yeah, I don't want to sign into that. Okay. Is this? Can I use this one? You have to find a key. Okay, you can use Bing. Does that work? Let's see. Can I just copy this? Same thing. I don't know. I don't use this very often, so I don't know. Chat. This is the thing, right? Yes. Is this ChatGPT 4 then? Okay, yeah. Okay. Should be on Bing, yeah. Alright, here, I'll just, modify it temporarily. Well, actually, let me look at something. So I have Hashmap.8. Let's see. So in here, yeah, the way, no, I don't want that. I want to look at just the docs for it. Let's see. So they, yeah. Yeah. Hashmap get, yeah, and you pass that. Ooh, okay. Yeah, so it actually returns it. So that's actually what I need to do. I just need to return the value. I can do that. Because index equals null. Yeah, then we can just return null. So that is fine. That is okay. So that is just what the issue is. So map hashmap index dot value. So I can just go ahead and do that. And this needs to be current dot value actually. That is fine. And then here as well, we can just return null. So then if we return null, then we know that there is a problem. So that should all be good then. We should be able to do that instead. And then we just have to change this because error is not right. So let's just do value equals. You have to dereference that one. Let's actually just make value a pointer. And then we'll send it to that. And then if value equals null, then we'll just handle error 1. So then it'll just crash. Yeah. And then we should be able to print the value at value. Let's see. Okay, so we do have some issues. So get from map instar from int. Oh, because I didn't actually update that so that it returns a pointer. So that is what we want to do. There we go. And alright. Ooh, okay, yeah, I need to do that. There we go. Okay. Same thing up here. Okay. There we go. Now it should work. Value set but not used, but we are returning. Oh yeah, because we don't need value anymore. So that is why I can get rid of that. Yes. Don't need that at all. Okay, so now, value is not declared. Yes, I need to get rid of all references to value. Okay, that is up here. Where do I do that? Right there. Perfect. Let's run it now, and we get the value. Let's go. Okay, so, we get the value. That's pretty cool. If it goes out of scope, though, I'm quite certain we lose it, because it's not allocated on the heap. So, yeah, if I do this, and then we can check the error in here. Go, and let me actually define value outside of it. So that's not actually what I want to do. So yeah, actually this is what can go out of scope because it's the pointer to this. So if I do that, so I don't need to put any of this into a scope block. It's actually this I want to do. So whoops. Let me just grab some of this. Let's see. Let's select the entire line. So what do I want to get rid of? Just all that. There we go. Alright, so then, yeah, we should be able to do that. Let's see. I don't think that there is any issues with that. But if I run it, it should... Okay, so it's still 12. So, oh yeah, because it's in the map. It's actually allocated. Alright. It's just if we have, like, a string, it wouldn't work. But, we can use a float now. So if we use just a float like this, equals 12.7. Sure, 12.7. There we go. And then we actually get, we won't be able to print the map. It's gonna try to cast it to an int. But we could do this and do pretty much the same thing. And I'm pretty sure this will work now. So it is more generalized. Yeah, 12.7. But you can see we try to print it and we cast it to an int and it does some really weird stuff. So I'm thinking, what if we use, let's see. So there's a few different ways we could do this. We could have the cast. We could have it be in some sort of macro, and then it just expands there. Or we could just have like we pass a value in there, so like, which is mapped to a certain thing. So like you could pass 7, and it would print an int, 6, it would print a float, something like that. So, I don't know, I feel like a macro would probably be better. I don't need to worry about it too much right now, though. So let me just cast it to a float, and then we'll be able to see the float representation. Yep, and we need to change this to float. There we go. Alright, now if I run that, we print it as a float. So that is cool. And yeah, so then it says weird stuff when you try to do doubles. Yeah, that's kind of fun. Funny stuff. Alright, so. That's a big number too. Okay. Basically, yeah, we can't pass a string though. So if I try to do a string, so let me just do, this is string. And make it a char star. Because it only... Well, it might still work. But the thing is, like, the scope is kind of limited. Because we don't allocate any space for it. So, yeah, we can still pass thing in there, and that should all be fine. Yeah, so that should put that in there. And then let's make this a char star. Okay. We want to print, not like that, but string. There we go. Run that, and... Yeah. This is, well, actually, this is also a problem. Yeah. do that and that. There we go. Alright, yeah, so now when I run it, it's kind of nonsense because we don't allocate anything for it. So it is just reading random stuff. So we need to, when we put it in the map, we do allocate space for the key. We could do that, but the only problem is we don't know the data type of it when we pass it in. That's kind of the point. So we don't necessarily know how much space to allocate. So I'm going to, let me open, let's see, do I still have it in here? I don't. Yeah, hashmap.h. This is, yeah, oh shoot, I did the same thing again. So in here, let me just kind of get some inspiration, see how this kind of handles it. So when you put it in a map, in there, yeah, you do pass the string length. No, so that is the string length of that. So, how do you, let's see, so you can put a string in here. How does it work? And then when you get the string, yeah, so you can just get anything. Yeah, remove something. So you do have to pass the string length of that, but we just get that when you pass it in here. So, like based on the actual key. So I don't know. Let's see. Okay, I'm going to actually look at the source code of it, and let's see what I can figure out. So it's, yeah, hashmap.h. In mine, I'm going to make it just a header-only file as well, rather than a C file like this. Similar to how this is done, because I want to just be able to import it into my projects and then start using it. So that is the point. Yeah, let's look at hashmap put. So this is not the implementation of it. So let me search in this file. There we go, right down here. Want the definition? Okay, let's see. Alright. Alright, so you need to pass. Yes, that's the hash map. The key, the length of the key, and then the value. Alright. And we don't modify the value, so that's why I said to const. We can do that as well. And I'm not trying to copy this either. Okay, so you said all that. Okay. Element was not already in use. Huh. Okay. So, alright, let me actually look at how I use it in one of my projects. I think in here, do I use it? Let me see. H. Do I? No, I don't. So it is in the Lexer actually. So let me look at the hash map. Is it not in here? Or maybe it's in the poster. Let's see. Hash map. I know I use it somewhere. Alright, yeah, so in the hash map. When we place something in the hash map, what do? Hash map put. Okay. Oh yeah, I see. So we need to, alright. So it's just onto the user to worry about that. Hello there, how are you doing? Alavaz, I think. Yes. Hello. Hello. Hello indeed. Yeah, so it's just onto the user actually. So that is, you just have to allocate it yourself. And I'm pretty sure I have memory leaks in here as well. Which is something I need to work on. But yeah, so that is okay, I think, actually. So, in here, let's look at hashmap put. Whoops, hashmap put. Yeah, so, okay, I guess we only put that in the hashmap. So, why do I need to pass it in there? Okay. Text. Alright, so, yeah. So that's not a big deal then. Coding in Elixir. Very nice. I've not ever tried Elixir. That's, it's functional programming language, right? If I understand correctly. Which I might not. Yeah. Alright, so I think that is okay. Alright, so maybe. Yes. Okay. Very cool. I need to get better at functional programming languages. I don't, yeah. I need to actually properly learn one. So I think this is actually pretty good then. Whoops. Alright, yeah. So, I can get rid of that. That was for testing purposes. So now, we can place things in the hash map, retrieve them, yeah, and like generic things, because we have the void pointers now, and it's not too difficult. So with the printing, that is something that I want to work on. So we have, up here, print map. So I think this could really just be a macro. Elixir is cool. It pattern matches almost everything. Pattern match function arguments. Pattern match. Yeah, I want to take a look at that. Yeah, so how does that work? Because I've used OCaml. That's really the only functional programming language, like actually functional. I've used JavaScript or whatever, but that doesn't really count, right? Okay. Let's see if I can understand what's going on. Okay, I don't understand what's going on. Yeah, and I probably won't. So, let's see. Okay. I just want to look specifically at the function arguments, because that sounds... Yeah, matching function arguments. There we go. Example, if you have your recursive function, and you can use fn0, and then when the times equals 0, the other function will be called. That's pretty cool. Pretty cool. And is that something that you can't really do in other functional programming languages? I don't know why I have a hard time saying that. Yeah, is that like more or less unique to Elixir, or is it pretty common? Like, I don't know. I don't really know that much about it. Yeah. Oh yeah, I don't understand the syntax, so not very helpful to me. But that is something definitely that I would like to look into. Yeah, don't need that open anymore. Close that. There we go. All right. So let's see what we got now. Yeah, so we can't do that with strings. So yeah, but we need to equals that. Okay. Let me see actually. So size of our times. Let me do this actually, and then do this is square. Okay. I think yes, at least you can in Haskell. Okay. Haskell. Yeah, I haven't used Haskell either, so. Okay. Don't have that. And then, let's see what happens. Yeah, so now it is just none. None stuff. And actually, I need to, stir copy. Yeah. Let's see. How do you use that again? Let me take a look. Yeah, stir copy. So the destination, which is thing, and then stir. Okay, so that is all that we need, I think. All right, and let's see. All right. Did you saw Go's memory arenas? No, I did not get into that. Let's see what that is. Go memory arena. Let me see. Is it? Let's see. Experimental memory management system. All right. To improve performance. Okay. It's experimental. Okay. All right. I didn't know. I did not know that they were doing this. Okay. To implement a memory pool. Yeah. All right. I know what an arena is. Yeah. This is official. All right. Yeah. Let's see. All right. Introduce concept of arenas. Okay. All right. Garbage collection. Okay. So when you're using the arena, then it doesn't run the garbage collector on that part, so you don't have the overhead of that? Or how does it work exactly? This probably explains, so I guess I don't need to ask, but spending a similar amount of time. Yep. Solution to this problem. Alright, yeah, so I guess so. Yeah. Okay. Let's see. Alright, 65%. Occasions is a good candidate for using arena. Okay. Depends a lot of CPU time. Yep, okay. Okay. This program for 19% of CPU time. Alright. Okay. This is pretty cool. Results of that. So yeah, I don't understand how to read this exactly. Okay. Build with three. Oh, okay, I can understand this a bit better. Looks cool, yeah. Okay, that actually, let's see, it looks more dramatic than it is, really, but it's still pretty good, like, compared to that. Yeah. That is pretty cool. Trade-offs and drawbacks, yep. Only use critical code paths. Uh-huh. Mm-hmm. Alright. Um, alright. We do not anticipate arenas becoming widespread. Powerful tool, but one that is only suitable. I mean, if it helps, it's cool, yes. Arena should be included in the standard library, however, it should be discouraged. Seago. Okay. Uh-huh. Well, yeah, I think it's, like, a feature that you don't necessarily, like, not going to use necessarily in every application, but it's still useful to have for when you need it. Yeah. Conclusion. Very cool. Yes. That is definitely cool, and I will try that out sometime, perhaps on stream. Yeah, yeah, that's what you saw. Yeah. So how do you? Whoops. Let me actually open that back up. The thing that I just closed, right here. Let's see. Was there like How do you set it up? I guess it doesn't have that. Okay. Go arena. Getting kind of sidetracked, but that's okay. Go arena allocator. Okay. There we go. Proposal, that's alright. Arena package. So you need this package. Okay. It's not. Oh, it's not available yet. Okay. 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 Yeah. Okay. I guess I will get back to this. So. Hello. Thing. Okay. Let me go back into this. Actually, in the tip.h, let's see. So I use the Hashmap in here. Let me look at Hashmap put. Alright. So this isn't very good code, but let's see. Value. Okay, Hashmap get. Okay, so okay. So we don't want to pass that. We want to just pass thing. There we go. That is what I want to do. All right, yeah. So I was, yeah, messed that up a lot. Now, if we just do this, then it should still work. I don't think we need to allocate it. Yeah. Okay. I was a little confused by that, but yes, that was the problem. So yeah, this actually works with different data types. That is pretty cool. So what is something else that could use for testing? Another data type. What about let's use a long double. Something like that, and then get rid of this. Just want to try a large data type. Because the pointer it's not going to be more than 8 bytes, so it should be fine. So then just pass the pointer to that in here, and make it long double. And then, yeah, we want to print that out. Can you do that, or do you have to do... I forget how it works. Let's see. Then let's do that. Alright, and build that. Alright, how do you do... You have to do double L. Let's... no, how do you print... Oh, it's capital L. Okay, it says right there. Yeah. Alright, and let's run that, and... Alright, so that did actually work. Cool. Cool beans. Okay, so we can use... like generic data types. That is cool. That might not be the right word exactly, but yeah. So now, okay, let's see. Yeah, so I'm going to make this a macro probably. So let me just copy that, or let me actually define. So this can just be print map, and we are going to take, yeah, we'll just take a single argument, which is the type that we want to cast it to essentially. So, yeah, and also like you'll need to, yeah, yeah, okay. So then let's do that. Something like this. Whoops. All right, and then you can get rid of that. I might need to actually do while. Get rid of that as well. All right, and then this is the closing, so that's the last one that we need. All right, so let me just yank this right up to the top. Okay, and then do that. So we don't need this function anymore. So this probably won't work exactly right. And it will need some adjustments, but we can try that. So here we want to put the type. So then like that. There we go. So that way we can cast it. So if we call print map, and then we want to print it as yeah, so just a what is it? So we want a long double, and we want to dereference it like that. There we go. Something like that. And let's see. So I messed that up. Yeah, so maybe that won't work. Oh yeah, we don't want to do that. Actually, I need to change this. So let's do type. There we go, like that. Okay, now it's a long double. Oh yeah, we need to provide this as well. How we're printing. I love how I just don't say copy anymore. It's just yank. Yes. Yes. Vim will do that too. Okay, so we need to also provide the printing type. So that is just the printing type, basically. And then we want to put that in here. So the key is always gonna be that. So we can just put printing type. All right. Actually, that's not gonna. We need to do that. All right. Something like that. I think that'll work. Let's see. So let's pass that in here. And it's just LF. There we go. Actually, I need to do that. All right, let me run that. And it looks like it actually works. So now we should be able to do char star as well. And then if we make this a string again, string. And we have to define it as a string, char star thing string. This can be a char star value as well. We can get that, and then I'll just get rid of the printing of the value. And we will just print that as a string. There we go. And let's see if that works. And it did not work, so I did mess it up. Because we need to remove these again. There we go. Okay, now print the string. Okay, so now yeah, now we can actually print it, and you can customize the data type, and that is quite useful. So we can put even more stuff into there. Yeah, actually for this we could just pass it like this thing. Let's see, thing. There we go, and that I think will still work. Perhaps. Let's see. Yeah, so that does still work. Can't do that with just values though, because it has to be a pointer. So, so yes. So we can do a couple more of these, and we can put whatever in here, and then we can actually change this to who la. Hello there, Bob Ross RTX. How are you doing? How are you doing? Well, just whatever, and then yep, I need variable still, but it does print it all out. So they all actually went into the same place on the map, which is interesting. Why is that? Do they all have the same hash? Huh. Well, we could actually expand this, and they shouldn't. Oh, I guess, yeah, there we go. Yes, so that's pretty cool. I'll make it 10. So they all did end up in the same place, which is kind of unfortunate. And it does make it slower, but doing okie dokie. How is your language coming along? Okay, yeah, we don't have to get from that anymore. Yeah, we don't need this, and we don't need... Currently trying to add Boolean expressions to comparison expressions. Very cool. Yeah, so let me take a look at that. Have you Let's see. Has there been anything, any updates since I looked at it? Like major updates? I don't know if you've updated this to the repo. Yeah. Let's see. Do you have examples? I saw before that you removed the old examples. Let's see. Runtime aired. Plenty of updates have came out. Very cool. Okay. Turn null. Okay. Yeah. So that's pretty standard. Let's see. So, let's see if I can remember. Let's see if I can remember what there was not in here. Arrays. Was there arrays before? Games. Guess the number. Ooh, can you get input now? Oh wow, this is a pretty big thing. Let's see. So you can get input. I don't think that was a feature before, right? If I remember correctly. Okay. Yes, I don't think there was arrays either. Massive updates on the website. Oh, okay. Yes. Let me see. Let me go to the website. Let's see. Input is a new feature. Yes, I thought so. Okay. Already better than JavaScript. Let's see. Already better than JavaScript. Yes, that is true. Okay. It's written in TypeScript, right? So yeah, TypeScript. Okay, let's see. Is there? Where do you see the updates? It's just in the docs. Test. Ooh, okay. This is a test. Okay. Frequently asked question. Where is the major updates? Is it an interpreted scripting line? Yes, that it is interpreted, yes. Docs are still being worked on. Some of the footer links have to be added. Oh, okay. I see. Where is the list of updates though? Oh, you meant massive updates on the website. Okay. I mean you updated the website massive. Okay, I thought you were saying the updates were listed on the website. Okay, I see now. Okay, yeah. The website has its own repo as well, right? Let's see. That's not what I wanted to do. Demi website, yes. Haven't uploaded the list of updates yet. That's going to come out when a new version comes out. Okay. What is the official version of it? Actually, I think it said on the website, didn't it? It was 0.0.3 alpha. Very cool. Okay, so this is the website, yes. I'll start that. So let's look at front end. Yes, that is what we're interested in. Source. I'm learning about interpreters via a book called An Interpreter in Go. Yes, I have heard of that book, actually. I've not read it, though. Okay. Index. Let's see. React. Very cool. Yeah. I don't know very much about web development. I used to. Not anymore. I forgot it all. Let's see. Started liking computer side setup stuff more than web. That was the thing I most did. I used to do web a lot as well. And now I don't. Really cool assembly programming book called Programming from the Ground Up. I have not heard of that one. From the ground up. Let's see. Alright. Let me actually commit some of the changes I made here, and then I will look at that. Let's see. Added void pointers. Go plus HTMX. That is something that I wanted to try, actually, is HTMX. I've not tried that. Some funny memes on Twitter, though. Or X. Yeah, where is the book website? Let's see. Is there no website for the book? Right here, summary. Alright, okay, program from the ground up. So, is this, like, what kind of assembly is it? Let's see. Why is there two? Wrong. Oh, this is the wrong book? Okay. Let's see. So what is the right book? Is this? This is the summary of the book. Is this the right book? Let's see. Is this the right book? Yeah. Using Linux assembly language. Okay. I'm assuming this is the right one, right? Okay. Right book. Okay. Yeah. So is it NASM assembly? That seems to be the most popular. Or is it GNU assembly, actually? That might be it. That would probably make sense. Let's see. Is there any... I don't want to pirate it or anything, but... Let's see. Alright, so this is the right one, yes. Let me see. How do I read this summary? GNU assembly. Yeah, okay. Yeah. Alright, download. Okay. Let me see. So it's free to download? Is that a PDF? I want to make sure I'm not pirating anything. Oh, okay, there we go. It's open here, I guess. So, this is the book. I'm not going to read it right now, but I'm just going to look through some of the stuff. So, let's see. Welcome to programming, your tools. I want to see some stuff. 15. Section.data. I have the hard copy. Yeah, it's... Reading books with the actual hard copy of it is better than a PDF like this, but... Okay. Yeah. So how in-depth does it go? Let's see, what is... dealing with files, that's cool. Okay. Oh, there's more down here. Okay. Counting like a computer, high-level languages. First C program. So it actually goes to C. Alright, so you can learn assembly and then learn C. How many people, like, in the modern age at least, have started, like, with assembly programming and then moved on to higher level languages from there? Like, that's obviously rather rare, but, like, how many are there? Because obviously, before there was higher level languages, like, there was just the machine code. Yeah. Using the... Alright, so that's using... I should probably read about using the debugger. I use this. Writing an interpreter and go. Yes, I will look at that as well. GUI program. Is this in assembly as well? Pretty cool. I should probably give this a read, because I've been meaning to learn assembly a bit better. I don't know about GNU assembly though. I don't know, NASM. I don't know if you guys have heard of that. NASM. You probably have. Or not NASM. Sorry, it is FASM. That's what I meant. That one is pretty cool. Flat assembler. It's been around for a while. It's actually got an entire operating system as well that is apparently still being actively developed. Let's see, where is the operating system? There was... I don't remember what it's called. But it's pretty cool. Everything is open source if you can read assembly. But you have to be able to read that specific kind of assembly as well. For the architecture that you're reading and such. Where is... I want to see the... yes, it's this one. Built with FASM. Yes, very cool. Yes. This is the one that I want to learn, actually, is flat assembly. Yeah. Has some high-level things on top of it, like a powerful macro system as well, even though it is just assembly. But yeah. Yeah. Can look at an example. Let's see. Accessing webcam and Windows. I don't want to download it. Okay, so I can't just see the code for it. That's okay. Now I want to look at, let's see, getting kind of off topic, but I want to look at this. The interpreter in Go. So I've not read this book, but I have heard some good things about it. Lexing, parsing. Parsing is something that I feel like I need to learn a bit better. That's the part that confuses me the most, like the grammar part. I don't know why. Like, it doesn't seem complicated, but I just don't understand it. Yeah, extending the interpreter. Let's look. Okay. Let's look at the final product. Source code, that's what I want to look at, really. Okay. Alright, yeah. Let's see, where is... So here... Yeah, we did it. Okay. Hello? Monkey program. Yeah, that is what... Is there the source code for that? A small C compiler? No. Okay. Yeah. One of the first pages, there is a zip file with the source code. But it's not just on GitHub or something. Because I'd rather just look on there. Yeah, this is actually the same one, I suppose. So I could probably look at that. Let's see. I just want to look at the syntax. Let's see. Let A equal 3, B equal 1.2. Alright. Oh, okay, so hard-coded constants like that. Okay. So are all of the... I guess it doesn't really matter. Never mind. Yeah. How usable is this language? It's interpreted. So, it's already, yeah. Let's see. Yeah, cool stuff. Alright, got kind of off topic. I think I'm going to go back to the Hashmap now. Yeah, let me see. So, yes, Demi, very cool. Definitely check it out. Yes, indeed. Demi-like. Yeah. And I have looked at this on stream before as well. Okay, so let's see where we are at here, because I don't remember at all. So I think we can print the hash map now. That is what we've got. So, print map. Yeah, so let me just, yeah, it's kind of weird that they're all colliding. So let's change, like, who to, something else. Something like that, and then run it. And there we go. So now it collides with that one. Okay. And then can be, and let's see where that goes. Does it collide? Okay, yeah. I'm going to come back. Alright. Have a good day and good luck with your program. Thank you. You have a good day as well. Yes. So that's kind of weird how much they collide. Because it is 10, but it still seems like, you know what I'm saying. Maybe, I don't know how to write. No, me either. Me either. There we go. That went to a different place, actually. So something that I would like to do is actually update the hash function. Because right now, it's not very good. So if we look at the hash function, it's just something completely random that I did. That I actually updated with this. I can get rid of that. Basically, it just takes the integer value of the character at this index, and then it multiplies it by 10 and divides it by 3. So it has, it still produces the same output every time and does what you would need, really, from one of those, but it's not ideal. There are some, let's see, let's actually see what this one uses, for the hash function. So is there just like a hash function? Let's see, I can't just search hash, so, because that is what I would like to know, because if, let's see, if we implemented a better hash function, then, like, the better the hash function, the better the hash map. Kind of. Not exactly, but I would make collisions less frequent. So, let's see. What do we have? What do we have? Alright, I don't see anyone. Let me just look up, like, hash map, hash. And let's see if there's any good ones. Okay. Let's see if there's anything good here. I mean, mine works, technically, but it's probably not ideal. Okay. Yeah, that's not what I want. I just want to see, just like a basic hash function. So, is there anything in here? Okay. Don't like that. Alright, let's see. Yeah, I don't want. Alright, let's see. Maybe. How Hashmap works in Java. Let's see. I don't care about Java. I just want to know what the function is. Let me just let's go to Google and let's see what we can find. So, keys and values in Hashmap. Yes, I want to know what the function is. Let's see. Does this have any hashing functions? Hash function. Yes. Let's look there. Is there a let's see hashing by division? Okay. So M. Let's see, where is hashing by division? Okay, multiplication. Of the hash. All right. I just want. Let's see. Okay. All right. Power of 2. Prime number. Yes. Where is non-uniform? Yeah. Okay. M is the size of the table. Okay. Although any value A produces a hash function. So just uses the golden ratio. Okay. So maybe I could do that then. So that is size of the table. Mod 1. Okay, so M. What is M? What is M? Hash digest of that. I don't know what that means. I'm not gonna lie. Okay. Hashing by division. Let's just look at that. K mod M. Alright, so what is K? Oh, size of value that you pass in. Okay. So let me try that. Let's see. So I'm just gonna mess around and see what we get. Let me just let's see. Let's make it here, return 0, and then we can just write it up here. So let's just print the hash of a couple different things. So hash of test, and then let's see, hash of hello, and hash of something like that. Let's build that. Okay, and now there's problems. So what does that mean? Oh, because the return value is that. Yes, we need to actually print that. Yes, I forgot that it returns a number. Okay. So let's see. So for now, that is what we get. So there is quite a few collisions. Like, it's only 10, though. Like, if we change the size to, like, 1024, then it would be like that. Yeah. They're all different. But, yeah. When it's 10, there is going to be a lot of collisions. That is kind of inevitable. But we can just maybe make a couple more of these. Like only 10 total. So like that, and then just slightly change them every time. Just into random stuff. There we go. And then we can look at the different values. And I messed something up. Right here, I need that. There we go. Whoops. And now, yeah, so we can see there is quite a few collisions though. Which is obviously an issue. So, Hashmap in C, nice. Yes, indeed. And I can provide the link there as well. There's the link. I don't know why it did it twice, but I think I'm gonna kick the bucket on Boolean operations. They are weird to implement. Yeah, that's what C did. They just kind of gave up and then later added it to the standard library. So I don't know why it sent that message twice, but that is the link to the source code. Sometimes what you need, though, when you're implementing something, then you just need to take a break, and then when you come back to it, you can implement it. Yeah, so let me just mess around with the hash function and try something like this. So, yeah. Let's actually look in here. So, okay. So, but we aren't using an integer as that, so we need the string to represent that. So I think just adding all the characters together can be the string representation of that. I think that is reasonable. Something like that. So now when we return that, it is just going to be based on the length. Well, I guess we could just set it to string length. So maybe do that. So it'll start out as the string length of key. Now I can just get rid of that, and let's see. Now if I run that, yeah, so now it's just based on the length of the string, and then it's also still mod, so that it stays in there. And then k mod m, so that is basically what we are doing here. Yes. So that way it can overflow and such, but then things that have the same length are going to collide always, which isn't quite ideal, because oftentimes you'll have things that are not very long. Like usually the key for it isn't going to be more than, say, 10 characters, so they are going to collide quite a bit. Yeah, so kmod 701. Okay, yeah, so linear probing, yeah, multiplication method. So this might wait until I finish member expression. Switch statement. Well, switch statements, yeah. Okay, let's see. Okay. Yes, I think you definitely should implement switch statements soon, though. That is a helpful thing. Have to come after classes and objects, though. Still have not got the classes implemented. Okay. Yeah, I know what you mean. Yeah. Okay, let's see. So multiplication, right? Let's look at that. So, first, the key multiplied by a constant a. Okay. Fractional part of ka is extracted. Alright, so just a constant a. So we'll just set that. So it's actually a float, though. Okay, let's do float of a equals 0.76. Sure. Why do you make a Hashmap implementation in C? Well, so I use Hashmaps all the time in my projects. Most specifically, in this one. Recently, yeah, I've been working on a virtual machine. And I use a Hashmap a couple different times in here. Actually, it's in the parser. I use a Hashmap in here, and it's not one that I implemented. And I like to kind of reduce the amount of dependencies that I have. So right now I'm using this one. Let's see, I can open it up. This one right here, hashmap.h. I can provide a link to that. But I did not want to have that dependency because it just has some things that I don't necessarily need. So I just trying to implement a relatively simple hashmap so that I could use that in my project and kind of port it all over. And then for future projects, I'm going to be using hashmaps all the time, so I want to have my own implementation that I can use, basically is the reason. Also to learn more about hashmaps, because they are quite interesting. Up to 1,000 lines just from the parser. Dang. Pretty big. Okay. So, what do we have here? So this is M, and the fuller of the result is taken. Okay. So let's see. So basically, so M is the size. So this is the size. Let's see. So mod 1, and then we have the hash mod 1. Okay. And then we multiply that by a. So hash times a. And let me just let's see, so k is that, there we go. Let's see, I don't know if it's like that, I'm assuming it's like that. And then we multiply it by hashmap size times that. So let me do it like that, actually, because I think that this is supposed to be evaluated first. There we go, and let's build that. And float to int, yeah, so I need to actually cast it to a float to use it. Let's just cast that to a float. And then use 1.0 for this as well. But then cast it to an int when I do this. Alright, and let's see. So, float and double. So yeah, I just need to do float of this. And, oh, you can't use mod on float. Ooh, okay, so that's not gonna work, actually. So I don't really want to use the fmod. So what if we use this as the int? Take the int of this, and then do that. I think that'll be fine. So there we go. Now we run that, and it's all 0. So I definitely did something wrong. So this is always 0. Well, so this, let's say, so it's the length, so that'd say 6 times a, so times 0.6. Okay, well 10, we'll just say that, and then we get 6 mod 1. Ooh, okay, 6 mod 1 is always gonna be, it's always gonna be 0. Yeah, that's an issue. So, so what are you modding 1? Actually, is it just a mod 1? Is that what it is? Oh, not gonna work. Let's see. Yeah. Yeah, okay. I don't know. Let's see. What is just a simple one? Alright, let me go back into here. Is there just, let's see, how many lines is this even? Yeah, almost 1,000. So, okay. No, that's not what I want. Let's see. So where is just the hash function? Because that is what I would like. Hashmap create, hashmap put. Yeah, iterate. Is this the hasher? Okay. So, where is that actually defined? Down here? Okay, so the seeds, you provide a seed, and then, ooh, okay. It's actually pretty complicated. Alright, on here. Iterate through that. Alright, that seems kind of complicated. I don't think we need something that complicated. So what is just a simple hash function? Let me just want to look that up. Let's see. Simple hash function for Hashmap. Let's see. Alright, okay, let's see. Key.hashcode. Okay. Alright, maybe there is one in here. And the pop-up's gonna pop up in a second, so. Okay. Map a key into one of the slots. Okay. Yeah, so that was what we were doing before. Where we do, yeah. Hash mod, hashmap size. So that is equivalent to that. We don't need the A anymore. And then that is what it returns. There is quite a few overlaps, and that is not ideal. Like, it is short, but there shouldn't be that many overlaps. Okay. Hence, it can be seen that this hash function can have the, yeah, collision. Yeah, so you want to reduce collision. So, multiplication method. Floor of n times, okay. So, do they have an example of that? So, multiply the key by a constant number, c. Okay, key times c. And extract the fractional part of that. Okay. Is that, hang on. 10, let's see, 18 okay. Ooh, okay, I see. So that is the point of the mod one. That makes sense. I guess I shouldn't have done that on my site. I can show what I just did. Basically, I opened Python, and then I was looking, so, like, say it is 10, and then that is the thing. Whoops, I meant to do times. So it's times, this is 0 point that, and then that is what we get. So then to extract that, you do mod 1, and that is actually the, fractional part of it. So that is the point of that. So you get the fractional part of that, and you multiply that by m, which is the size, and you take the floor of that. Okay. Is there a frac function? Yeah. Okay. Frac. But I don't want to link with the math library. I guess I could do that, though. It's not very hard to implement these, but I don't really want to. If I could spell properly. Math.h. So, let's see. So we can do this pretty easily. So, let's see. So we can do floor of m, which is the hash map size, times, and then hash is k, times c. So that can just be any fraction number. So float c equals 0. that. Or actually, well, I'll use pi for this, but they said to use the golden ratio, which I can copy and paste that in here after that. But so times c, and then let's see. So you take the frac of that actually. Holy frac. Okay, frac like that. Yeah. So I think we didn't link, so it's not gonna work. And I also didn't provide a semicolon. So let's just do that, and then build this. Yeah. Undeclared function frac. So, ooh, okay. Seems like there's not a frac. Frac function in C. Or is it because I did not link? It could be that. Mod F. That's C sharp. I don't want that. So, mod F. Alright, I might just use mod F then. So let me actually modify it so that we link with it. Yeah, just like LM. There we go. And that should work. And then I still think it is not, yeah, so frac does not exist, so we just need to use fmod. So we can just do this one right here. So, fmod of c and 1, and, okay, and then k is the hash. Hash times that. Alright, so, and we need to actually write this in parentheses. Like that, there we go, and let's build that, and capital C. And now that should be the function. So, our problem is that it can't go that large. That actually breaks things. So why does it do that? It's supposed to be constrained. So I must have done something wrong. Floor of that times that. Huh. Did I mess this up, actually? Let me actually try that in Python. So the size is 10 times the hash, so we'll just say it is 6, that's the length. Times, okay, fmod of that. Yeah. Yeah, okay. And let me actually do this. So then C is 0.31415, mod 1. So let's see what that is. I missed something there. Oh yeah, I forgot a closing. There we go. Ooh, okay. It is pretty good nowadays. Well, yeah, I wasn't saying there was anything wrong with it, but that's not what I wanted. Because I'm not using C sharp, so that is why. You need TypeScript for your own. Well, just learn assembly and then write it in assembly, and then you don't need. Assembly is a language technically, but also not really. Yeah. Okay, so. Yeah, I think what we need to do is this, and that changes the precedence of it. Yeah, so that is the issue, I think. I think we want to do fmod of hash times C, rather. 3D engine in TypeScript? That is quite interesting. Do you have a link to it, perhaps? Okay, so that doesn't work. Because I have an extra one right here. I think my Wi-Fi is dying. Is the stream still going? Yeah, okay, I think it is good. It's just kind of dying. Alright, yeah, so there is still some overlap, but it looks to be less. So that is a bit better. And it is constrained properly. Let's just increase this, or let's actually decrease it. Let's make it 5, sure. Let's run that. Yeah, so we still get, obviously there's going to be overlap when you have 10 elements, but it does look pretty good. C# virtual machine for your own language. Ooh, do you have a link to that? I would like to look at that for sure. Because I am actually working on a virtual machine for my own language, so always like to see those kinds of things. Alright, so we do have that. Let's make it 15, and let's see how the equations are for that. So, ooh, we do have a lot of 14, though, so that is a bit of an issue. I'm pretty sure I did everything right here, though, so I think that is good. So that is the multiplication method. Perhaps I should make a hash function for each different one. That's probably a good idea. So let's do big hash, and that just takes the key, and that basically just returns strlen of key times hash map size, and